Guys, welcome back to TechDose, and in this video we will look at the all O1 data structure problem, which is from lead code number 432, and this is based on design data structure type problem. Now let us look at the problem statement. In this problem, we are required to design a data structure to store the strings count with the ability to return the strings with minimum and maximum counts, and we need to implement the all1 class where we will have the constructor all1, and then we have 4 different APIs. One API is increase a string key where the key will be given and we need to increase the frequency of the given key. If that key is not present, then we set the frequency by 1. Otherwise, if it is already present, then we need to do the frequency plus 1. Similarly, for decrease, if the key is present, then we will decrease the frequency by 1. And in this problem, it is guaranteed that the key will already be present. Okay. Now in the get max key, we need to return one key which has the maximum frequency. If there are multiple strings with maximum frequency, then we need to return any one of them. And the same goes for get min key, where we need to return any one string which has minimum frequency, right? And we need to implement all these APIs in order of 1 average time. That means theta of 1 time. Okay. Now let's look at a simple dry run in order to understand our problem. According to the APIs, if I say that the call is coming for increase tech, so initially I do not have anything in our list, and let's say we will be maintaining it in a list. So we will be maintaining the string comma frequency. So let's say when the tech is coming, then I will be writing tech as the string and its frequency will be 1. So I'm maintaining a list. Okay. Now when the next item comes in as tech, so tech is already present, I will increase the frequency to 2. Now when the get maximum key is coming, then there is only one string and it has frequency 2. So the answer for this should be tech, that tech has the maximum frequency. Now let's say a decrease API is coming for tech. So I need to decrease the frequency of tech and make it 1. Again, if the increase is coming on dose, you see that the dose is not present in our array. So we need to insert another string dose and write the frequency equals to 1. Now if the increase is coming again on dose, so dose is present in our list already, so I will be increasing the frequency to 2. Again, when the get min key is coming, then the get min key should return the string, at least one string which has minimum frequency, and that should be tech. So here the answer will be equals to tech. Now when increase key is coming on tech, then the tech's frequency should increase and become 2, and then if it becomes 2, then in the next time when we have to get maximum key, then I will iterate and find out which one has maximum key. So both of them have maximum key, so we can return any one of them. So let's say I return tech as well. Fine. So this is the expectation of the entire problem, and we need to implement all these 4 APIs, increase, decrease, get max and get min key, in order of 1. That means order of 1 average time, which is called theta of 1, right? So let's look at some of the requirements in order to solve it. The first requirement is, let's start with get min key and get max key. How do you get the min and max in order of 1? Obviously, if you think, then an ordered list makes sense. If you make the list ordered, then you know that the first item will be minimum and the last item will be maximum, provided you have maintained in the non-decreasing order, ascending order, right? So let's say we have done that. Then if the list is ordered, and then if the call is coming for get min key, you know that the first item will be the minimum, and if it comes for the get max key, it will be the last item. So you have implemented that both in order of 1 time on average, right? Now let's consider the increase and decrease key. Let's say that I am calling increase on live. So what I need to do is I need to find out where the live is present. So I will have to iterate through the entire list. It can be present anywhere. So this becomes order of n. Whereas if again decrease is coming for, let's say, tech, then again I have to find where this tech is present by iterating through the entire list, and this also becomes order of n, right? So why this is linear time? Because I do not know where live is present, and also I do not know where tech is present. So in order to get around this problem, we can have a hash map where the key is actually the string is actually the key, and then the value of the map is the location, or you can say the address or index, whatever it is, right? So let's say for this tech, I can store here tech and say that it is present at 0. For this dose, it is present at index 1, right? So if we maintain this kind of map, then I can find out where live is present by just looking at, okay, live is present at index 2. So I can go to index 2 and actually change the frequency value, right? This can be done. But then what if the requirement also involved deleting the item, not just increasing and decreasing, but removing it from the list? Someone's frequency becomes 0, I will have to remove that item. So removing the item from the array is not order of 1, it is a linear time order of n, right? So in that kind of case, you cannot take an array. What is the next option? I think it will be a linked list, right? So if you have a location already known, you can use a linked list to remove the item. So according to our second requirement, if you want to reach to the key, that means the string, in order of 1 time, that means theta of 1 time, then you need an unordered map. If you take an ordered map, then it will be order of log n all the time. Okay, so that is why we will be taking unordered map. Now the unordered map's time will range from order of 1 to order of n, but in average it is theta of 1. Now for removal in constant time, if you are given the address, then you can use the linked list implementation to remove the node in constant time. Okay, so this is the map which we will be taking. Again, the unordered map that I had discussed about. The string is the key and the address will be the location of the node. Now again, if you see, I have already inserted 4 different string with 4 different frequencies and their address have been stored. So this address is as good as saying that this is pointing to this node. Okay, so when you have the address, you can jump onto that location very easily, right? It is a constant time operation. So now we have boiled down our entire data structure. What we will be using, we will be using an unordered map, a doubly linked list, because in a doubly linked list, moving forward and backward is easy. Okay, and the ordered list will be maintained with the same linked list. Okay, so the available options that we had was unordered map, unordered set. Now the set can maintain a collection of strings. Okay, and you can find out any item in theta of 1 time from an unordered set. And if you take an ordered map or set, it will be log n all the time, and that is why I will try to avoid this, because the question asks to solve in theta of 1 time. If you take an array, then the insert will be linear time at any given position. So we will be using a linked list so that the insert and removal will be always order of 1. Okay, so I think by this point you have understood about our choice of data structure in order to implement all O1. Now once we have done this, let's look at a dry run along with the code parallelly, right? So in the dry run, first I will be taking a head and the tail of a linked list as dummy variable. So here the frequency will be -10, so that this is just an impossible value. The frequency will range always from 0 to some positive number. So I am taking a dummy value, and I will be putting all the nodes in between the head and tail. Why did I take this dummy? So that all the cases can be handled with the same piece of code. If you make head as null and tail as null, then you have to separately handle the cases of if head is null, if tail is null, and so on, right? So the code logic will become more complex, and that is why we have taken this dummy. Now I will show you the code and the operation side by side for easier understanding. Now before moving on to the dry run, let me just show you the piece of code where I have declared the structure. So the node will contain an unordered set of string type which will be containing all the keys. So this means that if there are multiple strings, like let's say tech and dose are 2 different strings which is having the same frequency, let's say frequency equals to 2, then they can be present at the same place, that means at the same node, right? We do not need 2 different nodes for them, and that is why the collection of these strings will be stored in the unordered set, because finding if any string is present here is just theta of 1 time, right? We will be keeping a frequency which will be mentioning what is the frequency of this current node, and then we will be having a next pointer and a previous pointer, because this is a doubly linked list. We will be having a head and tail, right, as you must be knowing, and we will be having a key store map. So this key store map is this one which I had already shown you. So this map is the key store map. Given a key, where it is present in the linked list, it will be shown by the key store map, right? So that is this key store map. Now there are some helper APIs that I have written for the doubly linked list. If you can look at it, there is a get new node. Okay, so in the get new node you have to pass what is the key and the frequency. Let's say I pass the key as tech and the frequency to be equals to 1. Then it will create a new node and assign the key. This key will be inserted into the set, and then the frequency will be assigned, and then the next pointer will be made as null, and the previous pointer will also be made as null, and this node will be returned as it is. So this is the get new node function. But if you want to remove a node, then let's say that you had a node here where you had some previous pointer and the next pointer too, and there were some other nodes too, right? So there were some other nodes like this, and you want to remove this node. So what you will do is you will have to maneuver the pointers. You have to make the previous's next point to the current's next, and then the current's next previous pointer point here, right? And then you make these two pointers both as null, and then you delete this one. And these are the steps being shown here. So I have written a detailed explanation of each and every line by using the comment. So I think it will be very readable code, right? And then after this, I have written the add write node API. So in this add write node API, you will find that once you have a node, let's say you have a head node here, right? Let's say I'm inserting in the beginning, and you have a tail node here, and I want to insert a node after just the head node. Then I will be passing the node after which I want to insert a new node, which is current. After this, I want to insert the new node. Then what will be the key of the new node and the frequency of the new node? So I will get the new node. So okay, so this is the API for getting the new node, and I will name it as new node. Now the next pointer of the new node, so let's say the new node is here. Then the next and previous pointers were null initially, and now what I will do is the next pointer of this new node will be pointing to the current's next, and the previous pointer will be pointing to current. Now current's next will be made to point to this node, and then the next node of the new node, that means the next node of the current node, will be made to point to this node, right? And that is why this gets inserted in the middle. So this is adding a node to the right of the current given node with the given key and the frequency, right? So this is how we can create a new node and insert at any given position. Fine. So these are the helper APIs. So once you know about it, then let's start our explanation of all the 4 APIs one by one, and I will show you the code parallelly. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. So initially I will have head and tail by default, which will be declared in our main constructor. So if you look at the main constructor all one, then here this will run in the beginning. So head and tail are assigned with an empty string and with a frequency value of -10 because they are just dummy. And then what I'm doing is I'm making heads next equals to tail and tails previous equals to head. Okay, something like this. So I have already made this. Now we will be serving each and every API one by one. So the first thing that we are going to serve is increase tech. Okay, so there can be only two conditions. Either tech is already present in our list or it is not present. So if it is not present, like this is the case, then we will have to create a new node possibly. In this case, we have to create a new node. And I need to create a new node to the right of head and with the frequency equals to 1. So let's say with the get new node function, I will get a new node. And then I will insert this node here and make the next pointer point here, the previous pointer point here. The next pointer of this will be pointing here. And the previous pointer is null already, right? And these two will be delinked. So this is how we will be inserting a new node with the key tech, and then the value will be the frequency equals to 1. So since there was no node with frequency 1, that is why we had to make this node. Okay, and this with certain address, let's say OX1 is the address, the key will be inserted here, that tech is a key, and its address will be inserted. Okay, so this is our key store. So how did I even find that tech is not present in this list? Because I went to the key store and looked at the map, and in the key there was no key with the name tech, and that is how I know that it is not present in the linked list. Okay, now let's say that this is the state currently, and then now I want to call the API increase dose, right? Now there can be two cases, either dose is present or dose is not present. So in this case the dose is not present. Okay, so now what I will do is I will have to add dose word to the node with frequency 1, because a node with frequency 1 already exists. How do I know that dose does not exist? Again, you will be looking at the key store, and you see that the key is just having tech, it does not have dose. So after that, you know that it has to be inserted with frequency 1. So head's next node will always be the one which will have frequency 1 if there is a node with frequency 1. So you will check the head's next node. Okay, so this node is tech and its frequency is 1. So just input this dose into this tech. Since it is a set of strings, so I will just be inserting dose into this set. Now if you want to get the max key now, after having done this, then the max key will always be the previous of the tail, because I am maintaining ascending order. So the previous of the tail is having both tech and dose. So the max can be anyone. So let's return tech. You can return anything at random. And what about the min key? The min key will always be the next node of the head node. Okay, so the next node of the head node is having both tech and dose. So you can return anyone, and let's return tech. You can return anything at random. In a scenario where there is no node at all, then the get max key will be returning the previous node of the tail node. And you know that the previous node of the tail node is having an empty string, because that was already declared in our constructor, right? An empty string for head and an empty string for tail. So an empty string will be returned. That is what the problem actually expects, and the minimum key will be the one which is next to the head, and here also we have defined an empty string. So empty string will be returned. Okay, now once you insert this dose, definitely I will have to update this key store, and its location will be OX1 as well, right? So we will keep on updating the key store. While checking, first of all we will check from the key store to know if a key is present, and at the end, while inserting or even making a new node, you will have to update the key store. For every key there has to be an entry in the key store. Now let's look at the next operation which is coming. So let's say increase dose is coming, right? So first I will check from the key store, is dose present? Yes, it is present at OX1. So I can go to OX1, right? Now since it is present, I need to increase its frequency. So dose's frequency will become 2. But to the right of this node, is there any node which is having frequency 2? No, this is having frequency -10 if you remember, and this is also -10. So there is no node to the right of it which has frequency 2. It has to be immediate right, because I can just increase frequency by 1. Okay, so what I will do is I will have to remove this dose from here. So the dose entry will be removed from the key store. This is step number 1. The step number 2 will be to get a new node and insert the word dose, and then with the frequency equals to 2, and then make this node here point to this node, and this previous will be here, and you will be pointing here, and the tail will be pointing here, right? And you just remove all the links. So this is as good as saying that to the current node you are adding a right node. This API I have already shown you, right? So add right node to the current node at location OX1 with the frequency equals to 2. Now having seen this, let's look at the code for the increase API. So in the increase API, whenever a key is coming, either the key is present or the key is not present. Okay, so if the key is not present, then what we do is we need to check if the next node of the head node is having a frequency 1. If there is a node to the right of head which is having a frequency 1, then I do not need to create a new node. I will just insert it into the set, okay, to the next node of the head node. Otherwise, if there is no node with frequency 1, then I will be adding a right node to the right of head, and with the key of whatever was coming, and then with the frequency equals to 1. Fine. So I think this code is very readable. But if the key was already present, then what? So if the key was present, then I will get the current node where the key is present. I will find the location, and I will remove the current key from that node set. Okay, and after that I will find if the next node is having a frequency which is 1 greater than the current frequency, because I am calling an increase on that, right? If that is present, then I will simply insert it. That means if the current node is having, let's say, 2 strings tech and dose, okay, with the frequency equals to 2, but the right node is having, let's say, some character, let's say training, and it has frequency equals to 5, then the next node of this tech is not having a frequency equals to 3, because I'm, let's say, increasing the frequency of tech by 1. Then what I will do is I will create a new node to the right of this current node, and then I will add the frequency. That means I will create a frequency 3, and I will add tech here, and I will remove it from here, right? Fine. So the removal step is at 51, right? If it is not present. But if this frequency was 3, then I will not create a new node, but simply I will remove tech from here and add tech into the right side node. Okay, so this is being denoted in line 55, I think, and then creating the right node. If the next node is not having frequency +1, then I will be creating a new node. Fine. So I think it is very readable. After doing this, we need to update our key store, okay, with the new entry of the node location. So this is the entire increase function. I think you can just go through it and it will be very much readable. Let's now look at the next set of APIs. So let's say this is our current state and this is our key store. Now in this, if I have to make a call for get min key, then get min key will always be the beginning one. So just after the head node, so I will be returning tech. Get max key will be just the previous one of the tail. So I will be returning the tails previous. So if you look at the code, how I am doing that, then you will see that for the get max key, I am checking if the tails previous is head, then we will be returning just an empty string. Otherwise, we will be returning the tails previous any key. So I'm returning just the first key of the set. Okay. And similarly, for the min key, it will come in the beginning just after the head node. So if after the head node there is a tail node, that means we do not have any insertions yet, and that's why I will be returning an empty string. Otherwise, I will be returning just head next nodes, whatever string is present, I will just be returning that. Okay. So this is about the get min and get max, and this is definitely order of 1, you can say. Okay. So this is order of 1. Now let's say what happens for the decrease key. Now when the decrease on tech is coming, first of all we need to check where it is present, because in the question there is always a guarantee that the decrease key will be present. So tech is present at OX1. So I will be going to OX1. I want to decrease the value. So if I decrease the value, then this will be removed from this frequency 1. Now if it is removed from this OX1 node, then there is no other string here, right? And that is why this node has to be removed. So if you remove this node, then this pointers needs to be adjusted. Okay, so I have written a different API for this adjustment of pointer. Before deleting it, you have to make both the left and the right pointers, that means next and previous, as null for the current node, and then you can remove it. But once you are decreasing this, then the text frequency was already 1 and it will become 0. So it has to be completely removed from the list. And when you have to do that, definitely you have to remove the item from the key store. Fine. Let's say a decrease is coming after this on dose. So you will go to the key store and find out where it is present, OX6, right? So when you found out that this is present at frequency equals to 2, then what you need to do is you will be removing it from this node. Okay. I will be removing it from the key store because its location will change, or otherwise it will be completely removed. So dose is removed. It is removed from the key store as well. So now the frequency 2 node is empty. It does not have any string. So I will be removing this node as well. And again, an adjustment of pointers will happen and you will have only the head and tail pointers at this point of time. So when you just have the head and tail pointers, then you see that what will be the new frequency of dose? It will be 1. So there is no node with frequency 1. So that is why I will be creating a new node with the string dose with the frequency 1. And this entry will be given to the key store dose at, let's say, location OX9. So this is at OX9. Fine. And then the next pointer of head will be adjusted, previous pointer pointing to head. Again, the next pointer pointing to tail, tails previous pointing to this new node. Okay. And these two will be gone. Fine. So this is my adjustment. So you see that the decrease is also order of 1, right? This is a constant operation. You can say theta of 1 because the map is also theta of 1. So if you look at the code implementation of it, I think you can go through it and it is the exact same logic that we will be finding where the current key is present. I will be removing the entry from that node, and then I will also be removing that entry from the key store if the frequency was 1, right? And likewise, I will be completely updating the entries. I mean, you can just go through it and it will be very self-explanatory. I have written it in a lot of detail. So after having looked at all this dry run, you will be making out that all the APIs are theta of 1. Okay, and I hope you were able to understand it. you should go to my code and read line by line. You can take a notebook and just do a dry run. You will definitely get it. If you still have any problem, please comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.